This is Algebra 2, Lesson 86, and this lesson covers greater than, trichotomy axiom, and transitive axioms, and irrational roots. Alright, so this one has us graph x is less than 3, and we need the positive integers. So x is less than 3, that means that it could be any number that is less than 3. Positive integers means that we have to stop when we get to 0. Alright, so part of this is drawing your graph and knowing how big your graph needs to be and what numbers need to be on it. I'm just going to put 0 right here in the middle. That wasn't even at all. Let's see if I can make that look halfway decent. Alright, that's going to be 0. Alright, and then I'm going to do 1, 2, 3, 4, 5, and then -1, -2, -3. I probably don't need to mark all those. Alright, so x is less than 3. So that means it cannot be 3. It has to be everything that's less than 3. Positive integers. Integers are only whole numbers. So that means that it cannot be a fraction or anything in between. So it's going to be everything less. That's a whole number. So it's just going to be those two dots right there. So that is x is less than 3, and it is positive integers. Alright, next one. This one asks us to graph x is greater than -3. Alright, and remember with these, it's easy to remember which one's less than and which one's greater than, because the open side is wants to eat. It's like an alligator. It's chomping the one that's the biggest. So right there, the x is bigger because the open side is pointing towards, like it's pointing towards that way, right? Towards the x. The chompies, it's the chompies. The alligator wants to chomp whatever's bigger. Alright, so this one I'm going to have come on, pen. There we go. Turn my thickness down here. Okay, so this one I have x is greater than -3. Alright, so I'm going to need a 0 and -1, -2, -3, -4, -5, and that'll be 1, 2, 3, 4, 5. Okay, so x is going to be everything greater than -3, and it's going to be our real numbers. Alright, so on this one I'm going to use an open circle. I hope you guys remember this from last year. And then I'm going to draw a line going that way, so everything that's greater than -3. And remember, the open circle means it's not equal to, it's just greater than. Alright, when comparing two numbers, we have three choices. The second number is the same as the first number. Okay, that is going to be equals. They're equal. It's an equal sign. The second number is greater than the first number. So here's our first number. So 1 and 2. Here's our number and our number. Okay, this one, the second number is greater than the first number. So it'll be going that way, right? That one's second number is greater. The second number is less than. Okay, that way. Okay, the transitive axiom states that, okay, we're not even going to think about that. So we've got three choices. We can also negate those choices or combine two of those choices. So we can combine our equals and our lesser than. So that's going to look like that. Okay, we can combine our equals and our greater than. That'll look like that. Then we can negate those. So if we want to say not equal to, we can do that. If we want to say not greater than, we can do that. If we want to say not lesser than, we could do that. If we want to say not lesser than or equal to, we could do that. And not greater than or equal to that. Now, the transitive axiom is saying that if you it's not two of those, then it has to be the other. So like if we have something that is greater than, that means it could be, or lesser than, that means it could be greater than or equal to. It could not be greater than or equal to, right? So these are the same thing. All right, so if x is less than 2, that means that x is not greater than or equal to 2, okay? If x is greater than 4, then x is not less than or equal to 4, right? If x is greater than or equal to 1, then x is not less than 1. So hopefully that makes sense. So you got 3 choices. It could be 2 of those. It could be any greater than or less than with equals mixed in, right? Or you can use the negated. All right, the transitive axiom states that if A is greater than B, so we've got A is greater than B, right? And B is greater than C, B is more than C, then C is more, then A is more than C. So if we put these on a number line, and we've got A is greater than B, so we've got B down here, A up here. B is more than C, right? So C's down there. That means that A has to be more than C. I've got that written wrong. C. If A is greater than B, A is more than B, and B is greater than C, so B is more than C, it would be the other way around. Then C is greater than A. I typed it wrong. No, I didn't. A is more than C. Yes, A is more than C. I didn't type it wrong. It makes sense. A is greater than C, right? So if one number is greater than the other, it just means they go in a line, right? So A is more, B is more. That means A is more than both B and C. And you can say equal to. So if A equals B and B equals C, then that means that A has to equal C, right? So if you had A equals B, B equals C, that means A has to equal C as well. Okay, that's the transitive property, transitive axiom. All right, graph x is not less than or equal to -4. All right, so I know I'm going to have a 0 and -1, -2, -3, -4, -5, -6, just for good measure, and then we'll just do 1, 2, 3, 4 over here. Okay, so x is not less than and not equal to -4. That means that x has to be greater than -4. And we want to use only negative integers. So these are going to be dots when it says integers. We're going to use dots instead of a line. And they have to be the negative integers. So that's everything more than -4. So that'd be -3, -2, -1. And those are going to be your negative integers. All right, let's try another one. Graph -x plus 4 is not greater than or equal, or is not greater than 2, and these are going to be our real numbers. Okay, so for that one, we got to rearrange, we got to isolate that variable first. So if we've got negative, whoops, let me change that. -x plus 4 is not greater than 2. We're going to do -4. We get -x is not greater than 2 minus 4, that would be -2. So that means that x is not greater than 2. Okay, that would mean that our trichotomy axiom tells us it could be It's not 1, so it could be the 2 others. X would be less than or equal to 2. Okay, so this says that it's the other way around. Let's see. All right. Probably the best bet would be to swap that around first. So we're going to change this to be that before we even start. So we've got negative x plus 4 is less than or equal to 2. And then we do minus 4 minus 4. All right, and the problem is this negative. Negative x is less than or equal to negative 2. We've gotten there. All right, we need to solve for x, not for negative s. Thus, we multiply both sides by negative 1 and reverse the inequality symbol. So when you get rid of a negative, right, and you multiply both by negative 1, you have to reverse the symbol, right? So we're just basically flipping it around. So x is greater than or equal to 2. Negative x is less than or equal to negative 2. X would be greater than or equal to 2. So I'm going to say 0, 1, 2, 3, 4. Our reals right there, you know what that means. That means we can draw a line. All right, and so we've got 2, and it's greater than or equal to. That means that we can fill the circle in, and then we just run it that way. Greater than or equal to 2. All right, so be careful with that negative. It's negative. You're going to have to swap around the, so if it's facing towards the left, you have to swap it to the right. Okay, swap around your inequality sign there. Okay, graph negative x minus 4. Did I do the same thing twice? Negative x minus 4. Okay, no I didn't. Okay, so this, I'm going to go ahead and change that. So if it's not equal to and not greater than, it's just going to be lesser than. That's all that's left. All right, so I've got negative x minus 4 is less than negative 2. I'm going to say plus 4 and plus 4. And I'm going to get negative x is less than positive 2. All right, now when I multiply times negative 1, I'm going to get x. I swap this symbol around, is greater than negative 2. So x is greater than negative 2. So I'm going to put my 0 right here. Negative 1, negative 2, negative 3. And this is negative integers only. Up here it says negative integers. So the only integer that is greater than negative 2, that's a negative integer, is that one, and we just make a dot for that. So be careful about what your domain is. Your domain tells you what acceptable answers you can have, and they have to be negative integers. All right, this next part is about irrational roots. So this is a system of equations that are nonlinear, but one of the roots is going to be irrational. It's not going to factor, right? So we're going to have to use the quadratic formula to solve these kinds. So first thing I'm going to do is I'm going to rearrange this problem so that I've got y equals x plus 1. So I just move that to the other side, right? So I've got y equals x plus 1. Rearrange that. All right, now I need to square that. So x plus 1 times x plus 1, and that's going to be x squared plus 2x plus 2 plus 1. Oopsie. 1 times 1 is 1, right? Because I would have x times x is x squared. X times 1 would be positive 1x. And then another positive 1x, add those together to get 2x. And then 1 times 1 is 1. All right, so that means that y squared equals x squared plus 2x plus 1. All right, and now I have to substitute that into my other equation. So I'm going to have x squared plus y, and my value of y is right there, x squared plus 2x plus 1 equals 9. Now I'm going to say minus 1, minus 1. I'm going to combine these like terms. So I have 2x squared, those canceled, plus 2x equals 8. Alright, now I am going to factor out one of my x's. Actually, I can factor out 2 and an I can factor out 2 for sure. So I've got x squared minus x equals, I know what I need to do. Divide by 2 on everything before I can do that. Alright. Divided by 2, divided by 2, divided by 2. There we go. So I get x squared plus x equals 8 divided by 2 will be 4. Alright, x squared plus x equals 4. And then if we do minus 4, then we would get x squared plus x minus 4 equals 0. Okay, now we have to try to factor that, and it won't factor. So we're going to have to use the quadratic formula to solve that to get our x and our y. So we're going to need some room. Alright, and hopefully you guys have memorized the quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we just start subbing in these values. So here a is going to be 1. That's the coefficient of our squared term. B is going to be, that is a terrible looking one. Come on now. My pen's acted crazy today. B is going to be 1. And C is going to be negative 4. Okay. Alright, so x equals negative 1, because our b is 1, plus or minus the square root of b squared, so 1 times 1 is 1, minus 4 times 1, which would be 4, times c. So right here that would be 1, and that is negative 4. Negative 4 times negative 4 will be positive 16 over 2 times a. A is 1, so that's just 2 over 2. Okay, so then I have 1 plus 16. I would have x equals negative 1 plus or minus the square root of 17 over 2. Alright, so that means that I've got y equals 1/2 plus 17 over 2, and y equals 1/2 minus 17 over 2. Let's see. No, x equals 1/2. Alright, so x equals 1/2 plus or minus this. So x equals 1/2 plus 17 over 2, which would be 18 over 2. Right, and that is going to come out to be that would just be 9, wouldn't it? I think they leave it like that. Oh, because that's still under the square root box. Yeah, we can't do anything with that. Okay, never mind. That stays like that. So there's our value for x. And here's our other value is 1/2 minus square root of 17 over 2. All right, so then we have to plug these values in to find our y. So there's our x values, which is not very satisfying. I hate when it comes out and you're left with this crazy square root. Not fun. Don't like doing those. All right, now we can plug those back in to find our values for y. So we would say y, actually let's move this back around. So that was y equals x plus 1. So y equals 1/2 plus 17 over 2. The square root of 17 over 2 plus 1. 1/2 plus 1 would be 1.5. Plus 1. Oh, that's a negative 1/2. Almost forgot that negative on there. So that would be y equals, so this one would be y equals 1/2. 1 and negative 1/2 would be just positive 1/2 plus the square root of 17 over 2. And this one would be y equals, so we're going to put that one in with the minus. So if this was a minus instead of a plus, and that would just be the same thing. So 1/2 minus the square root of 17 over 2. And that is your answer, even though it doesn't look like much of an answer. Don't forget that these were negative on this side. Let me fix that. So that'll be negative, and that one's negative. All right, and that is how you work those. All right, let's move along to the next thing. Graph negative x is not less than or, oh, these are practice problems. So go ahead and pause the video, work these practice problems, and then I'll work them for you. All right, so this first one, we're going to graph negative x. All right, so first thing we want to do is change this using the trichotomy axiom. If it's not equal to and it's not less than, it has to be greater than, right? Because we only got 3 choices. So we've got negative x is greater than 4. All right, we got to get rid of that negative. So we could say x, we have to flip this, is less than negative 4. Okay, now we draw our number line. This can only be integers, so that's going to be dots. And we need to start at like x is less than negative 4. So we're going to put negative 1 right there, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. All right, here is our dots. X is everything that's less than negative 4. So that would be negative 5, negative 6, negative 7, negative 8. Now, let me look in the answer key and see if they put an arrow on the end of that. 86. No, they just did, yeah, they did an arrow on the end of this, so you would draw an arrow right there, meaning that it keeps going in dots. All right, not too hard. Just remember to flip that sign. Okay, one of these. We're going to have to use our quadratic formula to solve this. All right, so first we're going to rearrange this one, and we're going to get y equals x plus 1. Okay, and then we're going to square that. So we're going to say x plus 1 times x plus 1, and we're going to get x squared plus 2x plus 1. So y squared equals x squared plus 2x plus 1. All right, and then we're going to plug that value in here. So we're going to say x squared plus, now we get the y value, x squared plus 2x plus 1 equals 11. All right, now we're going to subtract 1. And we're going to combine these like terms right here. So we have 2x squared plus 2x equals, actually I should do minus 11 on both sides. So that would be, because we want it to equal 0, equals negative 10. Minus 10 equals 0. There we go. There's where they canceled and we got a 0. This side would be negative 10. All right, we could divide everything by, ooh, nope, we don't want to do that yet. Never mind, because we got to divide all our terms by 2. So we're going to want to go the other way and subtract by that 1 off of both sides. Okay, so that was equals 11. Now we do minus 1. So that would be equals 10. Okay, now we're going to divide by 2. And we're going to get x squared plus x equals 5. Now we can say minus 5. And we get x squared plus x minus 5 equals 0. Okay, now this is the part that we have to use quadratic formula for, our x squared plus x minus 5. I'm going to write this up here. X squared plus x minus 5 equals 0. That way we don't lose what we've got. Alright, now we're going to erase all this. And we're just going to start plugging those numbers into quadratic formula. Our A would be 1, our B would be 1, and our C would be negative 5. They just go in a line. It's going to be whatever your coefficient is. I can get rid of those as well. Okay, so quadratic formula, x equals negative b plus or minus the square root of b squared minus ac over, no, minus 4ac 4ac over 2b, I think. Let me look back and make sure that's right. I have not got that. Okay, so we got negative b plus or minus b squared minus 4ac over 2a. Ah, that needs to be an a. Only messed up one letter. There we go. Alright, so now we can start subbing in these values. So x equals negative b, our b is 1, so negative 1, plus or minus the square root of b squared, b is 1, so 1 squared is 1, minus 4 times a, which is 1, times c. Negative 5 times negative 4 would be positive 20. Alright, and then 1 plus 20 would be 21. That's over 2a. We'll go ahead and make that say 21. Right, because we've got, that's 1 squared is 1, and then we've got 4 times 1 times negative 5. Negative 4 times negative 5 is positive 20, times 1 is still positive 20, and that's 1 plus 20 is 21. Alright, now 2a would just be 2 times 1, which is 2. Alright, so that means that x equals negative 1/2 plus the square root of 21 over 2, and x equals negative 1/2 minus the square root of 21 over 2. Now we got to get our y values. So we're just going to plug those into our equation, which is y equals x plus 1. Okay, our x, so we've got y equals, our x value right here is negative 1/2 plus the square root of 21 over 2 plus 1. So we just took our x and we subbed in that value. So we can put these together. 1 minus 1/2 would be 1/2. So y equals 1/2 plus the square root of 21 over 2. And then this side would be the same thing. Y equals 1/2 minus the square root of 21 over 2. Let me double check that. It says negative 1/2 plus the square root of 21 over 2, positive 1/2 plus square root of 21 over 2. Yep. So when you write it, you'd write it as an ordered pair, which is 21 over 2. And then your other ordered pair would be negative 1/2 minus the square root of 21 over 2. And then another one. Mess that up. Alright, you need a comma right there. Yeah, that's not right. Hang on. Let me erase all that. My pen keeps messing up. It's making it hard. Okay. Hard to pay attention to what I'm doing. Worrying about my pen. Okay. I'm going to change colors for the answer. Alright, so we've got a parentheses and it's negative 1/2 plus the square root of 21 over 2 is our first, that's our x value. Our y value is 1/2 plus square root of 21 over 2. And the other one looks just like that. It's just these values right here. So with a minus sign in the middle. Alright, so that is it for lesson 86.